Hello guys, welcome to the Resultant. Is audio video clear? So let me share the session. Is audio video clear guys? Where are you all? Join the session. Join the session guys. Quickly join the session. We'll start our class. Okay, we'll start. So this is all about me. Arvind, hi. Okay, is there any problem with the streaming? Okay, so like, share and subscribe our channel. This is all about me. You can go through my profile guys. And we have the aim batch for you on our application going on. Okay, so this was the scholarship test which is going on, you will get the 85% scholarship. Voice is not audible. Wait a second, so don't worry, wait a second. Okay, there is a voice problem. I think the problem is now solved. Okay, so you will get 85% scholarship if your rank is 1 to 5. Okay, and if your rank is 6 to 12, you will get 70% scholarship. Now also these are the scholarship dates: 25th, 26th and 27th. Okay guys, okay, absolutely fine. And also you need to contact these numbers. Okay, absolutely fine. This is the RRB JE batch for the CBT2 examination. Okay, so the classes are going on right now. So we are discussing the SOM in the classes. Okay, you'll get the PYQ solution, live quizzes, test series and doubt solving sessions. Okay, okay guys, okay, the link is provided in the description or in the chat section for your scholarship test. Okay, you have scored 27 out of 30. Absolutely fine. A very good score. Okay. Now let us start our class. The first question of the day. The first question of the day. I want the answer. First question of the day. Which among the following is are the correct assumptions in the theory of simple bending? Which among the following is are the correct assumptions in the theory of the simple bending? So what are the assumptions? Which among the following is the theories of assumptions in the simple bending? What is the answer? In the simple bending, guys. Arvind is saying B is the answer. Anyone else? Anyone else in the chat section? So, in case of the simple bending, we know that the moment applied on the beam divided by moment of inertia I is equal to sigma bending stress divided by y extreme fiber distance, and that is equal to what? That is equal to E by I. E is the modulus of elasticity, and sorry, yes, E by I. M by I is sigma by y is equal to E by R. Sorry, it is E by R. Okay. Now the load is applied perpendicular to the axis of beam. Always there are transverse loads. Okay, we consider, so the first assumption is true. The second assumption, the beam is bent into the arc of the circle. Absolutely. So this R is the radius of curvature. It is the radius of curvature. We are assuming that the bending of the beam will be like the arc of the circle. So this is also correct. The beam is initially straight with the constant cross section. So we are assuming the beam is straight first, and then the cross section area is also constant. Okay, absolutely. So all of the assumptions are correct. All of the assumptions are correct. Next question for you. Next question for you. Next question for you. The most economical section in the bending is. The most economical section in the bending is. Which among the following is the most economical bending in the economical section in the bending is? What should be the answer? What should be the answer? So the most economical section in case of bending, I'll discuss the bending. So if I take the rectangular section first, guys, the rectangular section, absolutely fine. So if this is the neutral axis, this is the neutral axis, absolutely fine. Okay. In case of the I section, so I am taking the I section, guys. I'm taking the I section. So this is the I section, guys. This is the I section. Okay, this is the I section. So this is the neutral axis of the I section. So from these figures, it is clearly mentioned. If I take the rectangular section, bending stress will be maximum on the outer fiber. Here the bending stress will be maximum on the outer fiber. But the economical section, because the material is less for the I section as compared to rectangular section. So we are assuming that the I section is what? Your I section is most economical in case of the bending, guys. In case of the bending, okay? In case of the bending. So the answer should be what? Answer should be A. Next question. Okay. What is the answer? What is the answer? So Arvind is saying the answer should be B. Okay, a simply supported beam of length L. So I'm making the simply supported beam, guys, which has the length L. Absolutely fine. The length is L. Now, okay, carries a concentrated load W at the mid span. So it is carrying the load W at the mid span. Absolutely fine. Okay. Now, if width B of the beam is constant, so the B is constant throughout the span with the permissible bending stress as sigma. The depth of the beam is equal to at the mid span. So you have to calculate the depth at the mid span. So we know that the M by I value. We know that the M by I value is equal to sigma by Y value. Or I can write down the M by Z value is equal to sigma. No problem, sir. No problem. Everything is done. Okay. So at the midsection, I know it is a simply supported beam subjected to the load W at the midspan. So the moment at the midspan is WL by 4. That is the load multiplied by length divided by 4. Absolutely fine now. So the moment value is WL by 4. Absolutely fine. Divided by Z value for the beam. Z value for the beam. You know that rectangular section, it is BD square by 6. It is BD square by 6. And that is equal to sigma. That is equal to sigma, guys. We have to calculate the value of the D. So it is 6WL. It is 6WL by 4. Okay, it is 6WL by 4 BD square. And that is equal to sigma. Okay, I can calculate the D value is equal to D square is, okay, that is 3WL by 2B sigma. Okay, so the D value is under root of 3WL by, okay, 2B sigma. 2B sigma. So what should be the answer? The correct answer should be B. That is 3WL by 2B sigma under root whole. Okay, so B should be the right answer. Guys, B should be the right answer. Okay, next question for you. Next question for you. So we have the scholarship test. The link is provided in the description. Link is provided in the chat section. Okay. The scholarship test is live on our application right now. Okay. The scholarship test is live on our application. Okay. Out of the two beams of same material, now we have the two beams which has the same material and which have the same cross sectional area. The cross sectional area is also the same. One is a circular cross section and other one is the square cross section. Both of these beams is subject to the bending of the same magnitude. So they are subjected to the bending moment m of same magnitude. So both the sections would be equally strong. That is option number one. And both the sections are equally economical. That is question number two or option number two. And the third, square section will be more economical than the circular section. Square section will be less economical than the circular section. What should be the answer? Arvind is saying the answer is three. The answer is C. Okay. If I take the circular section, if I take the circular section, okay, in that case, if I write down the bending stress sigma, that is equal to m by z. Now the z, okay, so the figure which has the z value more, that means the strength will be more. That means the strength will be more. Okay. In case of the z for the square, that is greater than z for the circle. That is greater than z for the circle. You can compare. I'll write down the z of square, that is equal to BD square by 6. Okay. And I will write down the Z of the what? I will write down the Z of the circular section, that is equal to pi d what? That is pi d cube by 32. Okay. You can compare the two. You can compare the two. Okay. You will get Z of the square is greater than Z of the circular section. That means the square section will be more economical that as compared to that of the circular section. Okay, so the correct answer for this question is C. Okay, next question. Next question, guys. Next question. So, next question, guys. What should be the answer? The simple bending equation is given. The simple bending equation is given. It is a simple bending equation. Arvind Singh answer is C. Anyone else? Anyone else in the class? The simple bending equation is the simple bending equation. The simple bending equation, guys. So we know that the moment is m. We know that the moment is m divided by moment of inertia I of the beam. That will be equal to what? That will be sigma by y. Sigma is the bending stress. Y is the extreme fiber distance. And that will be equal to E by R. That will be equal to E by R, guys. Okay. That will be equal to E by R. So what should be the answer? M by I is equal to sigma by y is equal to E by R. Where is the answer? M by I, E by R, F by y. F is the sigma, that is the bending stress. Okay. F is the bending stress. Absolutely fine. So answer should be what? Answer should be C. Next question. Okay, this is also easy question. This is also easy question. The relationship between the radius of curvature R, bending moment M, and the flexural rigidity EI. Okay, what should be the answer? What should be the answer? The relationship between the radius of curvature R, bending moment M, and the flexural rigidity is given by. So we know that, okay, we know that M by I is equal to what? Is equal to sigma by Y. Is equal to sigma by Y, that is equal to E by R. So we have to calculate the relationship between, okay, we have to calculate the relationship between M by I is equal to E by R, is equal to E by R. Okay, you can calculate now. You can calculate now. You can calculate now. Okay, you will, if I see the first equation, if I see the first equation, your R value will be E by what? E by, okay, your R value will be E by M, EI by M. EI by M. Okay, absolutely fine. So your R value is, where is R value? Your R value, okay, this is not matching. This is not matching. Second equation. The moment will be equal to EI by R. EI by R. So second is matching. So the second option is matching. Your moment is E by I divided by R. Okay. And also, if I see this equation, your EI is equal to MR. Your EI is equal to MR. Okay. Okay. So this is not also matching. If I see the the last one equation, okay, your E value is equal to MR by I. MR by I. So it is MI, so it is not also matching. So the correct answer is what? The correct answer is B. Okay. The correct answer is B. Next. Easy questions, guys. These are easy questions. So the scholarship test is going on. Scholarship test is going on. Okay. So you will get 85% scholarship if you, okay, if your rank is 1 to 5. The link is given. The link is given. Okay. Link is given. What should be the answer now? The assumption in the bending of in the theory of bending of the beam is, the assumption in the theory of bending is, so the first number of assumption we consider in the bending, we consider the material to be homogeneous. We consider to material as homogeneous, as well as what? As well as the isotropic. Isotropic. Okay. Isotropic. The second, youngest modulus is same. Okay, we are taking the youngest modulus in case of tension. That is equal to youngest modulus in case of compression. Whether we apply the compressive force, whether we apply the tension force, the youngest modulus is same in both the okay loads. And all of the above options are correct. All of the above options are correct. So the right answer should be D. Next question. Next question. Next question, guys. Next. What should be the section modulus? Okay. So if I define the section modulus Z, so the section modulus Z is what? That is I by Y. I is what? Moment of inertia, and Z and Y is what? Extreme fiber distance. If I have the rectangular section, guys, okay. Now we are applying the loads. There will be the bending like this. There will be the bending like this. Absolutely fine. This will be the bending. This will be the bending. Absolutely fine. Okay. So let us suppose this is our what? Okay. Let us suppose this is our what? Let us suppose this is our neutral axis. Absolutely fine. This is our neutral axis. Okay, guys. Absolutely fine. So this will be the y value, extreme fiber distance. This will be also y value. So you have to take the y maximum value. Okay. So I is what? I is the moment of inertia. I is the moment of inertia. Okay. So z is I by y. Z is I by y. Okay, so Z is I by Y. So remember, when the Z value is more, the beam is strong. Beam is strong. Okay, beam is strong. So in that case, there will be less bending stress. Okay, okay, guys. Next question for you. Next, next question for you. It is BD square by 6. Absolutely fine for the rectangular section. Okay. If the moment on a beam is increased 3 times, now we are increasing the moment by 3 times. We are increasing the moment by 3 times. Then to keep the stress, in the beam same, so you have to keep the sigma same. So the section modulus should be, the section modulus should be, guys, we know the stress sigma is equal to, we know the stress sigma is equal to m by z. Okay, absolutely fine. That means the m will be directly proportional to what? Z. Okay, z. If the moment is increased by 3 times, so the moment is increased by 3 times, that means the z value will be also 3 times. Z value will be also increased by the 3 times. Okay, Z value will also be increased by the 3 times. So it is increased by 3 times. A should be the answer. Okay, A should be the answer. These are easy questions, guys. These are asked in AG examinations. These are all questions asked in AG examinations. So what is the answer now? What is the answer now? A rectangular beam of uniform strength. A rectangular beam has a uniform strength and subjected to the bending moment M. Okay, bending moment M has a constant width. Now the width is constant, guys. The variation in the depth will be proportional to. The variation in the depth will be proportional to. How can you calculate? The variation in the depth will be proportional to. Arvind, variation in depth. Variation in depth will be proportional to. Variation in the depth will be proportional to. Arvind, variation in 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 depth will be proportional to. variation in depth, whether it is a rectangular beam, okay, whether it is a cantilever beam or a simply supported beam. So the variation you are saying the M, the variation of depth. So we know that we have M by I value is equal to what, guys? Is equal to sigma by Y value. Okay, absolutely fine. Absolutely fine. Okay. So we know that M by Z is equal to what? M by Z is sigma. Okay, I will write down the moment is M divided by what? Sigma. Sigma value I can write down as BD square by what? It is BD square by 6. Okay, for the rectangular beam. That is equal to the sigma, guys. Okay. Now, I will write down 6M by BD square. 6M by BD square. Okay, that is equal to sigma. Now I have to see the variation in the depth. Variation in the depth, guys. Arvind, the variation in the depth. So I will write down the D is equal to under root of 6m, under root of 6m divided by B sigma. Okay. So the variation of depth is directly proportional to root of m. What should be the answer? The answer should be C. Okay, the answer should be C. Absolutely fine. The answer should be C. Okay. Next question. Next question, guys. So next, under root m, absolutely fine. Okay, okay. So don't worry. Circular beam of uniform strength can be made by varying Z in such a way. So we can vary what? We can vary its diameter, sorry. The diameter is varied in such a way. So the diameter is varied in such a way. So what should be the answer? So we have a given here circular beam. Okay, uniform strength can be made by varying diameter. So that means the strength is uniform. For the strength to be uniform, Z value should be what? Z value should be constant. Okay, Z value should be constant. Or sigma value, sorry. The bending stress sigma should be constant. Okay, the bending stress should be sigma should be constant. Okay, if I'm making the cantilever beam, okay, this is the cantilever beam. So I am making the cantilever beam with the varying diameter. So in case of the varying diameter, I know the sigma should be constant. Sigma should be constant. So when the sigma is constant, that means m by z value should be constant. That is why m by z value should be constant. Okay, m by z value should be constant, guys. What should be the answer? The answer should be A. The answer should be A. Okay, absolutely fine. The answer should be A. Next, the answer should be A. Okay, now this is the definition of the beam. This is the definition of the beam. So a beam is a structural member. Okay, predominantly subjected to what? So we are applying which type of forces on the beam? We are applying which types of forces on the beam? Anyone? The transverse. Okay. So always remember that the beam is subject to the transverse loading. What is the transverse loading? That is perpendicular to the axis of the beam. Let us suppose this is our beam. Okay, this is our beam. That is a simply supported beam. We'll always apply the load is perpendicular. This is the axis of the beam. This is the axis of the beam. So we are applying always the load is perpendicular to the axis of the beam. As we are applying, absolutely correct. We are applying the transverse loads. We are applying transverse loads on the beam. Okay, transverse loads on the beam. So the answer should be A. Transverse loads, the answer should be A. Okay, absolutely fine. Next question. Next question. Strength of the beam is proportional to square of it is. Okay, wait a second. I will share the session again. So what is the answer now? The strength of the beam is proportional to what? The strength of the beam is proportional to square of it is what? Square of it is depth. Okay. So we know that is proportional to strength. So that for the strength we are calculating the Z. Your Z value for the beam is, if we have the square beam or the rectangular beam, that will be BD square, okay, divided by 6. That means the strength is directly proportional. Strength is directly proportional to D square, okay, depth square. So the strength of the beam is directly proportional to square of its depth. So answer should be B. Answer should be B. Absolutely fine. The answer should be B. Next. Another question, guys. A simply supported beam of circular cross section with the diameter D and the length L. The length is L, carrying the concentrated load W at the center of the span. The strength of the beam is proportional to. The strength of the beam is proportional to. Okay, we know that Z for the beam, if it has the diameter D, the strength is directly proportional to, what, guys? That is equal to, directly proportional to Z. And the Z value should be what? Pi by 4 of what? Pi by 32 multiplied by the D square. Okay, sorry, D cube, diameter cube for the circular beam. So the strength is directly proportional to what? D cube. D cube diameter cube. So the answer should be what? Answer should be C. Absolutely fine. The answer should be C, guys. Okay. Arvind, don't make the silly mistakes. Don't make the silly mistakes. Don't make the silly mistakes, please. Okay. So what is the answer now? A beam of rectangular cross section. Absolutely fine. Okay, the beam of rectangular cross section. Beam of rectangular cross section, guys. Okay, the cross section is given. The cross section for the beam is given. Okay, I'll solve this question. Wait a second. So Arvind is saying the answer is 300. The answer is 300. So let us make the example clear. A beam of rectangular cross section, absolutely fine, is subject to the moment of 20 kilonewton meter. It is 20 kilonewton meter. The maximum bending stress. The maximum bending stress. So we know that the bending stress is sigma. That is equal to m by what? M by z. The moment applied is, that is 20, okay, 20 kilonewton. Okay, kilo, I will multiply 10 to the power 3. Multiply, okay, I will take the kilo, I will take the Newton meter. I'll take the Newton per mm or Newton mm. So I will multiply again by 10 to the power 3. So this will be Newton mm, Newton mm. The moment will be in Newton mm divided by Z value. So what is the Z value for the rectangular beam? We know that it is BD square by 6. It is BD square by 6. So it is what? It is 6 multiplied by 20 multiplied by 10 to the power 6 divided by what? Divided by B value is 100. Multiplied by D value is 200. Okay, the square is also there. Okay, so it should be 6. It should be 6 to, it is 1 to 120 multiplied by 10 to the power 6 divided by what? So I will write down 200 multiplied by 200. That will be what? That will be 4 multiplied by 10 to the power 4. Absolutely fine. Multiply by 10 to the power 2. Okay. So this will go, this will go. So it is 120 divided by 4. How much is 120 divided by 4? That is 30 Newton per mm square. That is 30 Newton per mm square. So what should be the answer? The answer should be A. Okay. Okay. Don't make the silly mistakes, please. So the answer should be A. Absolutely fine. The answer should be A. Next. The answer should be A. Okay, the scholarship test is going on. Link is given. Scholarship test was available on 25th. Now it is available on 26th and 27th also. Okay. Okay, you will get 85% scholarship if you are ranking from 1 to 5. 1 to 5. Okay. Okay. Absolutely fine. So what is the answer now? What is the answer now? Anyone? Arvind, please share with your students also or with your friends also. Please share the session with your friends. Okay. So what is the answer? The ratio of flexural strength of two squares beams, one placed with its side is horizontal and other placed with one vertical. Okay, vertical diagonal. So the in the first case, I'm having the square like this. I'm having the square like this. Okay, absolutely fine. So two squares beams, one placed with its two sides horizontal. So the sides are horizontal, and the other place it with one diagonal vertical. Okay, now the diagonals are vertical in the second case. Now the diagonals are vertical in the second case. Okay, so these are the two cases. These are the two cases. What should be the answer? So in the first case, the ratio of flexural strengths, that is the z. Okay, that is the z value. That is the z value. How can you calculate z? Okay, when the square is okay, when the square is like that, that is the rectangle. Z value can be written as, if A is the side, so the Z value can be written as it is A cube by 6. A cube by 6. Okay, absolutely fine. Now, sir, the sides are A. Okay, the diagonals will be what? The diagonal will be, this diagonal will be, okay, how much is this diagonal? A root 2. Okay, A root 2. So we can calculate the Z here. The Z will be simply I by Y. What is the I? I value you know, that is A cube, A power 4 by 12. A power 4 by 12. Absolutely fine. Divided by, what is Y value? Sir, Y value extreme fiber. This much distance. This much. This much. Okay, this much distance. That will be what? That will be A root 2. A root 2 divided by 2. Absolutely fine. So you can calculate now. You can calculate. It will be A cube. Okay, it will be A cube divided by 6 root 2. 6 root 2. Now the ratio of, so you have to calculate the ratio of this Z to this Z. Okay, so this is Z1. Let us suppose this is Z2. So Z1 by Z2 is how much? Z1 by Z2 will be a cube by what? A cube by 6 divided by what? A cube by 6 root 2. 6 root 2. Okay. So this all will go. It will be only under root 2. So what should be the answer? Under root 2 should be the answer. Okay. Under root 2 should be the answer. No under root 3. No under root 3. Remember, it is under root 2. Okay. It is under root 2, guys. Next question. Next question. Again, the scholarship test is going on. 26th, 26th and 27th. Okay. You will get 85% scholarship. Remember this. Okay, the syllabus is technical. Link is pinned. Okay, link is pinned. So, in case of the maximum bending stress, in case of the maximum bending stress, in an I section occurs at where it occur. In case of the I section, the bending stress will be maximum at what? Extreme fiber, that is the outermost fiber. Outermost fiber. Outermost fiber. Absolutely fine. So it should be outermost fiber. What should be the answer? Answer should be B. Outermost fiber. Answer should be B. Okay. Next. कहाँ पर गेट का कहाँ पर है एग्जाम? अच्छा गेट का. चलो मैं बोलूंगा आपको, मैं बोलूंगा, डोंट वरी. So if W is the width of the rectangular cross section beam, okay, if width of the rectangular cross section beam is increased by 10 times, now we are increasing the width, okay, by 10 times, and keeping the cross sectional area unchanged. Cross sectional area unchanged, okay, the maximum shear stress will be. Then the maximum shear stress will be. Then the maximum shear stress will be. Okay, what is the maximum bending? What is the maximum shear stress in case of the rectangular beam? What is the maximum shear stress in case of the rectangular beam? Okay. Guys, you know the tau maximum for the rectangular beam is how much? That is 3 by 2 of tau average. 3 by 2 of tau average. How can we write down the tau average? Tau average is simply the force upon the area. The area is B into D. The area is B into D. Absolutely fine. Okay. Now, sir, the shear stress tau max is inversely proportional to depth. Inversely proportional to depth. Sir, the depth is increased. So the depth is becoming 10D. Okay, 10D. That means the shear stress will be equal to what? It will be reduced by the shear stress tau max will be 1 by 10th of tau max. Okay, because the relation is inverse. So the answer should be what? The answer should be B. The answer should be B na. Absolutely fine. The answer should be B. Are you getting my point? Okay, are you getting my point? Absolutely fine. Next question. So what is the answer? So the ratio of average shear stress. Okay. So you are doing it wrong, Arvind. Average shear stress to maximum shear stress. Please mark down the right answer. So guys, we are doing the average shear stress, tau average, to what tau maximum. So what should be the answer? You know that tau maximum is 3 by 2 of tau average. 3 by 2 of tau average. Okay. The answer should be 2 by 3 because it is ulta. Because it is ulta, that is the reciprocal. So the answer should be what? The answer should be 2 by 3. Okay. The answer should be 2 by 3. So the correct answer is D. Okay. Remember the scholarship test is going on. Link is given in the chat section. You will get 85% scholarship. Okay. So you will get the complete technical course only for 500 if you are scoring the rank of 1 to 5. 1 to 5. Okay. If you are scoring the rank from 1 to 5. Next question, guys. Next question. We'll get all the technical and non-technical syllabus of RRB JE 2. Okay, RRB CBT 2. So I want the answer for this question now. In a simply supported beam, maximum shear stress in a triangular section. Altitude at occurs at. In a simply supported beam, maximum shear stress. What is the location of maximum shear stress? What is the location of maximum shear stress? C is the answer. C. Arvind. Okay. If we have the rectangular section, guys, with the altitude as h, absolutely fine. Okay, let us suppose this will be the neutral axis. So this will be tau neutral. Okay. So the tau neutral will occur from the base at what? At h by 3 from base and 2h by 3 from what? From the vertex. Okay, absolutely fine. But it is the tau max maximum shear stress. Remember, the maximum shear stress will always occur at h by 2, at h by 2, okay, h by 2 from the base, and h by 2 from what? H by 2 from the vertex. So it will be tau max here. It will be tau max here, okay. So tau max location will be at what? It will be at the h by 2 from the base, okay, from the base, or from vertex, okay, or from vertex, or from vertex. So what should be the answer? Okay, there is no answer provided. There is no answer provided. Okay. Okay, it is saying from h by 3 from neutral axis. Okay. So you have to calculate this distance now. You have to calculate this distance now, guys. Okay. So this distance will be what? Sir, it will be the overall distance h by 2. H by 2 minus this distance, that is what? H by 3. That is okay. That is h by 3. So I will write down h by 3. Now you can calculate, that is h by 6. So the answer should be h by 6. The answer is C. Okay. The answer is C. So you have to calculate this distance. From the neutral axis now you have to calculate this distance. So it is h by 3. So you will calculate this whole h by 2 minus h by 3. Okay. You will calculate the h by 6. Okay. Absolutely fine. Next question. Next question. Next question. The maximum magnitude of shear force due to uh, the maximum magnitude of shear stress due to the shear force F on the rectangular section of area A at the neutral axis. 3F by 2A. Okay. So we know that shear tau max is nothing. Your tau max is nothing, but that is equal to what? Tau max is equal to 3 by 2 of tau average. So the tau average can be written as, okay, force upon area. Shear force upon area. What should be answer? Answer should be C. Okay. Easy questions, guys. Easy questions. Quickly mark down this now. Mark down this now. Okay. Mark down this question now. So when a beam is subjected to the bending, the shear stress in the top fiber will be, okay. The shear stress in the top fiber will be. How much is the shear stress at the top fiber? So let us suppose this is our beam, rectangular beam. Okay. Rectangular beam. Okay, this is the neutral axis. I am making the diagram. Okay, the variation is parabolic. The variation is parabolic with the maximum at the neutral axis. Okay, this is tau maximum. With the maximum at the neutral axis, zero at the outer fiber. Zero at the outer fiber. Okay, zero at the outer fiber. Absolutely fine. So the beam is subjected to what? Is bending, the shear stress in the top fiber will be. That will be zero. Okay, top fiber will be zero. And the bottom fiber will be also zero. Okay. So let us take the example of the I section. So in case of I section, I am making the what? I am making the variation, guys. I'm making the variation. Again, the variation is parabolic. Okay. The variation is parabolic. We know, guys, your shear stress tau is inversely proportional to the B. Inversely proportional to the B. Sir, here it is more B. Here it is more B. So the shear stress will be less. Up to this point, up to this point. Absolutely fine. Up to this point. Now, sir, the B value is decreasing. B value is decreasing. That means tau value will be more. So the tau value will be more. Till what, sir? Tau value will be more. Till this section. Absolutely fine. Till this section. Now, sir, there is again decrease. There is again increase of B. B value increases. Tau value will decrease. Okay, the tau value will decrease. And the variation will be like that. The variation will be like that. Okay, absolutely fine. The variation will be like that. If I am taking the plus sign, if I am taking the plus section, okay, make the plus section, make the plus section. The variation, okay, I want the variation, guys. I want the variation. So we know that I want the variation. Sir, at the top the breadth is less. That means shear stress will be more. Up to this junction, absolutely fine. Now, sir, B width is more. Shear stress will be less. Shear stress will be less. Okay. Up to this portion, absolutely fine. Now there is again the okay. There is again the B value less. The shear stress will be low. Okay, this will be the variation. Okay, this will be the variation. Okay, guys, next question. In case of the circular beam is now the ratio of the shear stress to the average shear stress of a circular beam is what? The ratio of the average shear stress. Okay, the ratio of maximum shear stress to the average shear stress of the circular beam. So it is 3 by 4. What are you saying? It is 3 by 4 or 4 by 3? Arvind, you are not marking it right. It's a maximum shear to average shear. I have the circular section. Guys, I have the circular section here. Okay. Let the diameter is small d. In case the tau max is nothing but 4 by 3, that is 33% more than the average. 4 by 3 of tau average. 4 by 3 of tau average. Absolutely fine. And now I can write down the tau max by tau average. By tau average. Okay. That is equal to 4 by 3. Okay. So I'll write down an important point also. Your tau max is what? Your tau max is 33.33% more. Okay. More than what? More than tau average. More than tau average. Okay. Absolutely fine. So the answer should be 4 by 3. D should be the answer. Average to maximum is 3 by 4. Absolutely fine. Average to maximum is 3 by 4. Absolutely fine. No problem. But the tau maximum to the tau average is what? That is the 4 by 3. Okay. That is the 4 by 3. Next, guys. Next. Next question and the last question to be discussed. Remember the scholarship test 25th, 26th, and 27th. Okay, 27th. The link is given in the description. The link is provided here in the chat section. Okay, okay. If you rank better 1 to 5, you will get 85% scholarship. That means you will get the complete non-tech and technical batch for only 500. Okay, for only 500. Okay, absolutely fine. Absolutely fine. What should be the answer? Okay, this question is repeated question, guys. This question is repeated. For a circular section, the relationship between the tau max and the average is 4 by 3. Average is 4 by 3. This is repeated question, guys. 4 by 3. Absolutely fine. So let us take the diamond section. Guys, let us take the diamond section. In case of the diamond section, make the variation, okay? Sorry, not the variation, okay? Not the variation. Not the variation. Okay, where is the tau max? So it will be tau max at the neutral axis. Absolutely fine. Okay. Tau max at the neutral axis. No, no, no. It is not tau max here. The tau max will occur here. Tau max will occur here. Okay. And the tau max will occur here. Tau max will occur here. If the total height is h, if the total height is h, okay. So this distance will be what? This distance will be 3h by 8. Okay. Okay. This distance will be h by 8. H by 8 na? Okay. H by 8. H by 8. Okay. Absolutely correct. Okay, and the tau maximum is what? And the tau maximum is also 9 by 8 of tau average. 9 by 8 of tau average. Okay, you know how tau average is calculated as force by area. Force by area. Okay, okay, guys. Okay, another question. Another question. Another shape factor is 2. Okay, the shape factor is 2. Absolutely fine. Another question of discussion. Another question of discussion. A rectangular beam of width 100 mm. Absolutely fine. Is subjected to the maximum shear of 60 kilonewton. The maximum shear force is 60 kilonewton. The corresponding maximum shear stress in the cross section is 4 Newton per mm. The depth of the beam will be the depth of the beam. I want the depth of the beam, guys. The depth of the beam. Answer is 150 mm. Okay, I will see. Okay, I will see the answer. Don't worry. So we know that the tau max is always the tau max is equal to what? That is equal to 3 by 2 of tau average. The tau average is what? Force upon the area. Area can be written as B into D. For the rectangular section, absolutely fine. So we know that the tau average is given as 4 Newton per mm square. 4 Newton per mm square. That will be equal to 3 by 2. multiply by shear force is what? 60 kilonewton. Okay, maximum shear force of 60 kilonewton. So write down 60 multiplied by 10 to the power 3 in the newtons. Okay, divided by B value. The B value is 100, and you have to calculate the D value. Okay, so the D value will be nothing but 3 by 2 multiply by 60 multiply by 10 to the power 3 divided by what? Divided by 100 multiply by 4. You can calculate now. So you can calculate now, guys. 10 and 20. So here will be, okay, it will be 3 into 6, that is 18. Okay, it is 18 multiplied by 100. Okay, divided by what? Divided by 2 into 4. 2 into 4. Okay, that is 900 divided by 4. 900 divided by 4 is how much? How much, guys? 900 divided by 4, that is 225 mm. 225 mm is the answer. Okay, हमने मैक्सिमम शेयर फोर्स नहीं कंसिडर किया, डोंट वरी. So the answer should be D. Okay, okay, guys. So this was today's session. This was today's session, guys. Okay, this was today's session. Okay, so like, share, and subscribe. Quickly, I will tell you what I have for you. Quickly, I will tell you. So we have the AIM badge on our application. Okay, the AIM badge is on our application. So we will get the 400 hours of live classes. You get the 400 hours of live classes. You will get the PYQ solution test series and the doubt solving. And remember the important thing. Remember the important thing. The scholarship test date. Okay, the scholarship test is going on. So it was on the 25th, 26th, and 27th. Okay, we'll get the scholarship at 85%. If your rank is 1 to 5. Okay, 1 to 5 is 85% scholarship. Also, if we rank 6 to 12, the rank will be the scholarship will be 70%. Okay, okay, guys. So these are our faculty. Okay, if you need further support, you can contact these numbers provided. You can contact now Abhinav sir. Okay, the numbers are provided here. The numbers are provided here. Okay, the 85% scholarship. 85% scholarship, guys. Okay, so thank you everyone. Thank you. Thank you so much. So like, share, and subscribe our channel. Okay, thank you so much for being with us. Thank you so much. Thank you, guys. Good night. Thank you.